This is problem 8-148 from section 8.3.2. Given the polynomial p of x equals x to the third minus 6x squared plus 7x plus 2. Part A, what is p of 2? So all we're doing is plugging in 2 for every x value. So I have 2 to the third minus 6 times 2 squared plus 7 times 2 and plus the regular 2 on the end. Okay? So if you multiply this out, you're going to end up getting an output of 0. So p of 2 is worth 0. Use the remainder theorem to find one factor of that cubic. See the math notes box. In the math notes it says if you have a p of some number that gets you 0, that means there is no remainder. So that means it's a factor. So x equals 2 would be a factor. So I'd write it as x minus 2. That is a factor. That works. So that's one of our factors. Okay, so part C says use b to find another factor. So I'm going to use this, and I'm going to divide my cubic function by x minus 2. Okay, so I'm going to write this x, we'll write it here, x to the third, the regular equation, x to the third minus 6x squared plus 7x plus 2. And I'm going to divide that by x minus 2. I'm working backwards to get the top part of the box. That's what I'm doing. Alright, so I know the first one has to be x to the third because it's in my answer, and it has to be in the first box. So working backwards, this would need to be an x squared. X squared times negative 2 is negative 2x squared. Okay. Now my diagonals are like terms, so they need to be added up to be negative 6x squared. So this term needs to be negative 4x squared. Negative 4x squared, negative 2x squared equal to negative 6x squared. So this up above part needs to be negative 4x, or for those things to multiply to work to be negative 4x squared. Okay. So now multiply negative 2 times negative 4x gives me positive 8x. Again, my diagonals need to add, and this time to be 7x, so this would need to be negative 1x in order for that to work. This final answer is just everything in the box added all together. Okay, so that's all we're doing. We're just doing the generic rectangles backwards. So in order for negative 1x to be in this top box, this would have to be negative 1. Negative 1 times x would be negative 1x. Finally, this gives me a positive 2, which it should work because that means there's no remainder, and that's what we saw by plugging in 2. So here we have x minus 2 is what we divided by times the top of our box, x squared minus 4x minus 1. So the other factor for part C would really be this part right here, the top of our rectangle is what we found. But if we multiplied those together, we would get the cubic function. Part D says find all the solutions for this. Find all the zeros. So I'm going to set each of these equal to 0. Okay? So the first one's pretty easy. We got x equals 2. We knew that. But the harder one is this quadratic we still need to solve. So I'm going to do the quadratic formula. Alright, so opposite of b would be positive 4 plus or minus the square root of b squared minus 4 times a times c, which is negative 1, divided by 2 times a. Okay, so I have x equals, I'm looking for my two other roots. Square root of, I'm going to end up having 16 plus 4, which is a 20, divided by 2. We're going to simplify that 20 to be the square root of 4 times the square root of 5. This I know is really worth 2, so that becomes outside my radical. Plus or minus 2. I don't know the square root of 5 off the top of my head, so I'm going to leave it as the square root of 5 divided by 2. My 2's may cancel with each other, so my second and third roots, or zeros, is going to be 2 plus or minus the square root of 5. Okay, so that's 2 of them right there, and we also had x equals positive 2 from plugging that value in and having no remainder. So that is how we would go about there. Use one of our factors to divide the big polynomial by in order to find the rest of the factors.